Hello grade 11 students. Today I am here to teach you an important geometry lesson, Equiangular triangles. That's your chapter 14 in your textbook. So we'll see first ratio of lengths. When you take a straight line and AB and C is given into the ratio 2 to 3. How can we write down the ratio in between AC to CB? AC we can write as AC distance is 2 and CB 3. So we can write 2 to 3. We can write as a fraction as well. How can we write 2 to 3 as a fraction? So I can write same thing AC to CB as AC over CB is equal to 2 over 3. Now take this one. If you take this length AC to AB now. AC is what? You get 2. What is AB? Total distance you have to take there. 2 plus 3, 5. This one CB. CB here. That's 3. AC. AC now 2. CB to AB now. CB is 3. AB is 5. So we'll try to write down the same thing as a fraction. I can write this one as AC over AB is 2 over 5. This one CB over AC is equal to 3 over 2. Now try to write down this one as a fraction. CB to AB is equal to 3 over 5. Now look at this triangle. Again, P is divided the AB line into 2 to 3 ratio and Q point divided the length AC to 4 to 6 ratio. How can we write down AP to PB? AP to PB is 2 to 3. As a fraction, AP over PB is equal to 2 over 3. Now look at this one. AQ to QC. AQ to QC. How can we write down? That's 4 to 6. You can simplify this. Now when you write like this AQ to QC as a fraction, you can simplify and write down 2 over 3 as well. 2 to 3. 4 to 6 is same as 2 to 3. Now we'll look at ratio between areas of two triangles with the same height equals to ratio between base lengths. What it says, when you get two triangles with same height, think about this triangle and this triangle. So there's a triangle ABC and P is this point. It says ratio between areas of two triangles with same height. So same height means here to here you get same perpendicular height for both triangles. ABP triangle, ABC triangle and APC triangle, all with same height. It says when you get two triangles with the same height, the ratio between the areas is equal to the ratio between base length. Now look at these two triangles. We'll consider A, B ASP triangle and APC triangle. What's the area of ABP triangle? Base is BP, so half. So area is equal to half. What's the base length? BP. And height is, we'll put x or something. AX is the height. And half times base times height. So this is area. I'll write area of ABP triangle. Then we'll take the area of APC triangle. What you get? Half times APC is now here. Same height. So half time. Now the base length is PC. Half times PC times the perpendicular height AX. Now we'll take the ratio between these two. When you divide 1 and 2, what happens? I am getting area of APB over area of APC triangle is equal to half BP AX half PC AX. Now, can you see here AX get cancelled out with this AX, half get cancelled out with this half. So, what is remaining? You are getting the area. The ratio between two areas is equal to the ratio of the base lengths. BP and PC are the base lengths of the two triangles. So you need to remember this is an important theory in geometry. When you get two triangles with same height, the ratio between areas is equal to the ratio between the bases. Now we'll apply that theory in these examples. You are asked to find the area of ABP. ABP is this one. So we'll put X is the area. So according to the theory, what can you say? The area between the two triangles X and this area is given 15 square centimeters. That's equal to the ratio between base lengths. What's the base length here in this triangle? 2. What's the base length here in this triangle? 3. So just you can write down the ratios and then cross multiply and find x. So you can cross multiply. So 3x equals 15 times 2, 30. So 3x equals 30, x equals 30 divided by 3. That's 10 square centimeters because x is about an area. So square centimeters is the unit. Now take the next example. You have given two triangles and the two areas given separately. So find x. X is this length, base length of PSR triangle. So what's the theory? The ratio between bases. I can take this side first. The ratio between bases is equal to the ratio between the areas of the triangle. So 12 over 8 because I took x first. This base first means this area you have to take first. Now cross multiply and find out x. 8x equals 12 times 2. What's x? 12 times 2 divide by 8. So 2 times 4, 4 times 3. So what's x? 3 centimeters, because this is about a length. So it's centimeters. Now we'll take these triangles and try to write down ratios. Two triangles given. You are asked to find out the ratio between AP and PB. What's the theory? The ratio between base lengths is equal to the ratio between areas. So AP belongs to this triangle. APC triangle, area of APC triangle. PB belongs to this triangle, PBC triangle. So the area of PBC. Now look at this one. Two triangles given, AQ to QC. So what is AQ? Belongs to this triangle. So that's equal to area of PQA or APQ triangle over QC belongs to this triangle, PCQ triangle. So area of PCQ triangle. Now look at this one. You get several triangles here. We need AP to PB. So you have to select the appropriate triangle. So you can either take, now if you take, this is as the other vertex point, you can write as AP to PB as this triangle over this triangle, or you can take the vertex point as C. So I'll write both. If you take AP to PB, think about this triangle first. This triangle, these two triangles. Then how can you write AP to PB? I can write APQ triangle over PB means PBQ triangle, area of PBQ triangle. Or same thing I can take with the bigger triangle. If I take the bigger triangle, this one, now think about this triangle. What's the area? APC triangle with PBC triangle. So same ratio. Now take the next one, AQ to QC. Which triangle you can take? Either this triangle or the bigger triangle. I'll first write down the smaller triangle. AQ to QC is PAQ triangle. That's area. PAQ triangle. PQC. QC means PQC. PQC area. Or if you take the bigger one, AQ with the bigger triangle, that's ABQ. ABQ triangle, area over QC means QB. BCQ area. So when you are taking the ratio, make sure that you take the proper triangles. Now there's a theorem in this unit. It says a line drawn parallel to a side of a triangle divides the other two sides proportionally. So we'll see what it says. We'll take this triangle ABC. A line drawn parallel to a side of a triangle. We'll take this one. This line is parallel to this one. Divides the other two sides proportionally. So think about this is PQ. So it says proportionally means the ratio between AP to PB and AQ to QC both are equal proportionally. Means that's the theorem. Now we'll try to prove that. So what you know? We know ABC triangle PQ is parallel to BC. We have drawn a line parallel to one side. So PQ parallel to BC. So we'll do a small construction. So we'll connect PC and BQ. Connect PC and BQ. And what you need to prove? You need to prove that the ratio between these two lengths are proportional. So we'll take, that's what you need to prove. AP to PB is equal to AQ to QC. So that's what you need to prove. And we'll try to prove that. When you take these two triangles, we'll take these two triangles. These two triangles will take A, B, Q triangle. But you can write about the areas. We can write down APQ area over PBQ area is equal to the ratio between bases AP to PB. So we did that before. That's first one. And when you take the other ratio, this side, APC triangle. APC triangle, what can you write? When you take APC triangle, we can write APQ triangle area over PQC. Triangle area is just the ratio between bases AQ to QC. Take this as 2. Now look at these two triangles, the denominator PBQ triangle, PBQ triangle. This one and the other denominator is PQC triangle. PQC triangle is this. What can you say about these two triangles? These two triangle areas are the same. Why? What's the reason? Same base with same set of parallel lines. In between, same set of parallel lines. So we can say PQC triangle area is equal to the area of BPQ triangle. What's the reason? Same base PQ and in between same set of parallel lines. Same set of parallel lines. So if these two are equal, what can you say about the denominators? PBQ is same as PQC triangle. So we can write from 1 and 2, these two are equal. So this side is equal to this side of the ratio. So when these two are equal, we can write AP to PB is equal to AQ to QC. So that's the ratio we need to prove. So what it says in this theorem, when there's a triangle and when you draw a parallel line to any one side, the ratio between the other two, when you take a triangle, when you draw a parallel line to one side, what happens? The triangle divides the other two sides proportionally. So this is another important theory in geometry. Now we'll try to apply that theory. Look at the triangle carefully, ABC triangle. These two lines are parallel. If the two lines are parallel like this, what can you write straight away? The ratio between the lengths BP to PA, here to here, here to here is same as here to here. BQ to QC. Now apply the theorem in this situation. These are the two parallel lines. So what can you say? PX to XQ. PY to YR. Here you can take other way as well. If I want to take the other value first, how can I write? I can write XQ to XP. Then YR to YP. You can take either this way or the other way around. Now we'll take this one. Two lines are parallel like this. Then the ratio between the lengths are equal. So we can write KP to PM. KP to PM is equal to KP to PM. Then LQ to QM. These ratios are equal according to the theorem. Now we'll take these examples and find out the unknown letter X. So these two lines are parallel. So that means the ratios are equal. I can start with this side because this is the unknown letter. X over 3 I can write as 4 over 6. So X is, we can cross multiply. 6x is equal to 3 times 4. X equals 3 times 4 divided by 6. So 2 times 2, 2 times 3, 3 get cancelled out. You get X as 2 centimeters. This one, X here. So you can start from this side. X to 6. X to 6 is equal to 8 to 4. So what is X? Multiply 8 times 6 divided by 4. So 4 times 2, 2 times 6 is 12 centimeters. You try this one now. The unknown letter is X here. So we can start from here. X to 3. X to 3 is same as 6 to 2. So X is 6 times 3 divided by 2. 2 times 3. 3 times 3 is 9 centimeters. Now we'll take the example 1 in your textbook. In triangle PQR, the line XY is drawn parallel to PR. So these two lines are parallel. Find the length of RY. Where's RY? Here, this is the X letter. If PX is 4 and XQ is 2 and YQ is 3. Now, how can we apply the ratio according to the theorem? We can start from here. X over 3 is equal to 4 over 2. Now, X is 4 over 2 multiplied by 3. So, 2 and 2, you get 2 times 3, 6 centimeters. So, here, this is according to the theorem related to ratio of lengths. So you can give the reason as according to the theorem related to the ratio of lengths. Example number 2. Based on the information given in the figure, find the values of A and B. Look at carefully and identify whether there are parallel lines. When you take these two parallel lines, what are the two triangles you can get? This triangle. So, according to that triangle, what can you write? We can write AY to YF is equal to 8 to 5. Then, what are the other triangles you can get? Can you see? This triangle. I can take this small triangle. This line is parallel to this line. So, according to that triangle, I can write AY to YF is equal to B to 4. Now, look at these two triangles. Look at these two ratios. Same thing on the left hand side. So, we can see 1 is equal to 2. So, I can write down 8 over 5 is equal to B over 4. Now, cross multiply and find B. B is equal to 8 over 5 times 4. So, 32 over 5. So, you can write down the decimal answer. 6 for 20, that's 4. So, 6.4 centimeters for the B value. How can I find the A value now? You have to select the appropriate triangle. Now, when you take this triangle, you get the ratio between A and this value. So, with what we have to take the other ratio, this triangle and this triangle. These two triangles we have to take separately. So, we'll take BDE triangle. I'll write here. I'll take BDE triangle. I can write down A to 5. A to 5 is same as XE to xb. That's my first equation. And then take this triangle, BGE triangle. In this triangle, I can write xe to xb is b to x, xe to xb is 10 to 4. That's my second equation. Now see, these two are equal. These two are equal. So when the right hand side is equal, I can equate 1 equals 2 here. So a over 5 is equal to 10 over 4. So what's a? 10 over 4 times 5. So 2 times 2, 2 times 5, 25 over 2, or I can write as a decimal number 12.5 centimeters for A. Exercise 14.1. In each of the following figures, the lengths of some line segments are denoted by unknown terms. Find the values of those unknown terms. Look at this diagram. Unknown is here. Two lines are parallel like this. Then you can apply the ratio. So we can write 8 over 3 here to here is same as 4 over 6. So what's A? 4 over 6 multiplied by 3. 3 and 2, 2 times 1, 2 times 2, that's 2 centimeters. Look at part 2. These two lines are parallel. Then you can apply the ratios. B first. B to 8, I can write 3 to 4. So what's B? B is 3 over 4 times 8. 4 and 2, 2 times 3, 6 centimeters. Look at part 3. Unknown letter is here and these two lines are parallel. You can apply the theorem. X to 8 is equal to 2 to 4. So what's X? 2 over 4 times 8. 4 and 2, 2 times 2, 4 centimeters. Next one. What's the unknown letter? Now this is not straightforward like before. D is here and the total length is 12. So we need to write down this part in terms of D. Whole thing is 12. This is D. So what is this one? 12 minus D. Now apply the ratio. We can write down D to 12 minus D is equal to 5 to 3. Because these two lines are parallel. Now cross multiply and find D. 3 times D, 3D. 5 times 12 minus D. Open brackets. 12 times 5, 60 minus 5D equals 3D. Take minus 5D to this side. 15D equals 60. D equals 60 divided by 15. What's the answer? 4. So that's 4 centimeters. Next part. The whole length is 15. This is y. So we have to write down this one in terms of y. That's 15 minus y. We know these two lengths are parallel. You can apply the ratios. So I can write 15 minus y to y is same as 2 over 3. Now cross multiply and find out y. 3 times 15 minus y equals 2y. Open brackets. 3 times 15, 45 minus 3y equals 2y. Take minus 3y to the other side. It becomes plus 3y. Plus 3y, 2y. You get 5y. 5y equals 45. What's the value of y? Divide by 5. You get 9 centimeters for y value. Next one. Which one is the ratio here? F is given, F is given. So you can write down any order. So we'll write down this way. So these two lines are parallel. F over 4 is same as 9 over F. When you cross multiply, you get F into F. F squared is 9 times 4. 9 times 4 is 36. So what is F? Square root of 36, you get plus or minus 6. But this is about a length. You can't get negative values. So F is 6 centimeters. Question number 2. Based on the information in the figure, find the values of A and B. Look at carefully and see whether you can write down the ratio. Here, if you take this one, what happens? This is also unknown and this is also unknown. So, better to take this triangle first. So, we'll take ABC triangle. ABC triangle. Then we can write down the ratio. A to 3 is same as 8 to 6. Why? These two lines are parallel. So, you can apply the theorem. So, what's A? 8 over 6 times 3. 3 times 1, 3 times 2, 2 times 1, 2 times 4. You get 4 centimeter for A. Now, you can apply to ACD triangle. ACD triangle is, when you take ACD triangle, we'll take B first. B to 6 is same as 3 to A. A is now 4. What's B then? 3 over 4 times 6. So 2 times 2, 2 times 3. 9 divided by 2. Or you can write this one as 4.5 centimeters. So that's the B value. Now we'll take the next one. Question number 3. In the given figure, FG, DE, BC all are parallel lines. Also AF is 6 centimeters and DB is given 3. AG is 8 and GE is 8 centimeters. Find the lengths of the line segments FD, we'll put X for that, and EC, we'll put Y for that. You need to first take the appropriate triangles. If you take ADE triangle, this one you can find X. X2, these two lines are parallel, so you can apply the ratios. X over 6 is 8 over 8. So what's X? 8 over 8 times 6, you get 6 centimeters. Now, how can we find out Y? You can take ABC triangle. So when you take ABC triangle, Y to this whole thing you can take. Here, this whole thing. So Y to 8 plus 8, 16 and 3 with x plus 6. X we found 6. 6 plus 6, 12. Now you can cross multiply and find y. So y equals 16 times 3 over 12. 3 times 1, 3 times 4, 4 with 16, that's 4. So y equals 4 centimeters. So what is y? We can write down y is EC length. What is x? X means FD length. Question number 4. In the given figure, DG is parallel to FC, EG parallel to BC, AD is 6 centimeters, AD. So this is 6 given, DE is 4, EF is 5, GC is 18, and you are asked to find the values of x and y. What are the appropriate two triangles? So here, these two lines are parallel. So we'll first take AFC triangle because only x is unknown there. So AFC triangle. When you take AFC triangle, these two lengths are parallel, so we can apply the ratios between lengths. So what's the ratio? I can write x over 18 is same as 6 over 5 plus 4, 9. So what's x? 6 over 9 times 18. 9 times 2, 2 times 6, 12 centimeters. Now we'll try to find out y. Y is here. And what are the two triangles I can take? So when you take y, I have to take ABC triangle. In ABC triangle, I can't take this length because there's no parallel line. So I have to take this distance to this one to find out y. So what is this distance? Y plus 5, and here 6 plus 4, 10. Now we can apply the ratio. I'll start with y plus 5 over 10 is equal to 18 over x. X is now 12. We found before. Now cross multiply and find out y plus 5. So first we can simplify. 6 times 3, 6 times 2. So 2 times y plus 5 is equal to 10 times 3, 30. 2y plus 10 is equal to 30. And then take 10 to the other side. 2y equals 30 minus 10. That's 20. So what's y? Y equals 20 divided by 2. That's 10 centimeters. Question number 5. As shown in the figure in the triangle ABC, the line ED parallel to BC externally divides the sides BA and CA produced. Also AE is 2 centimeters, AD 3 centimeters, and AC 4 centimeters, AE and AC 4 centimeters. The length of the line segment AB is denoted by X. This is X. You are asked to find out these answers. Now, this is not like before. We can't see the two triangles. We know these two lines are parallel. So, we need to identify. So, what we can do, we know these two lines are parallel. So, if this angle is here, what's the equal angle there? This one. Because alternate angles, this angle is equal to this angle and this one is equal to this angle. So we have to think about appropriate ratio. If you take this side first, we have to take the appropriate length. So that's double angle line, so that's x. So which one tally with this x? 3, opposite to double line. Then when you take, this is x, and if you take the other one, this side, that means opposite to this angle, that's 4. Opposite to that angle is 2. So you can take the ratio like this. So x equals 4 over 2 times 3, 2 times 2, you can get 6 centimeters. Or you can draw the two triangles on top of each other. So second method, I can do ABC triangle is there. So two lines are parallel. Which one comes to this side? So the D point comes here, because the D angle and B angle both are equal. So corresponding angles are equal. This angle is equal to this angle. So then what is AD? This is 3. What is AE? That's 2. AB is x. So what is this length? X minus 3. AC is 4. So this is 2. So 4 minus 2, you get 2. So this way also you can do the same question. So if you are using this way, what's the ratio? X minus 3 to 3 is same as 2 to 2. Then cross multiply, x minus 3 equals, here 2 and 2 get cancelled out. So x minus 3 equals 3, x equals 3 plus 3, 6 centimeters. You get the same answer either this way or the other way. But we see this method is easier than this one. So how can we fill the blanks? So which ratio is suitable here? Fill in the blanks. DB. DB is here. DB to DA. So this should be DA. DB to DA is same as EC to EA. So EC to EA. Question number 6. Based on the given information in the figure, find the values of x and y. Now again, you can use the ratio. Now, you can straight away take ABC triangle and find out x. So these two lines are parallel. So what's the ratio? Appropriate ratio is x over 9 is equal to 4 over 6. So x equals 4 over 6 times 9, 2 times 2, 2 times 3, 3 times 1 with 3 times 3. So 3 times 2 is 6. So 6 centimeters for x. Now how can we find out y? To find out y, you need to find out corresponding ratio. So here, if you take this angle, this is equal to this one. This angle is equal to this one. Now, we can take the appropriate ratio. If you take y is opposite to this angle, that becomes 6. Then if you take the 6 ratio, that's opposite to this one line, that's 9 here. Now find y. 6 over 9 times 6 when you cross multiply. 3 times 2, 3 times 3, 3 times 2. 2 times 2, 4 centimeters for y value. Question number 7. In the given figure, A, B, C, D and E, F all are parallel. AC is 3 centimeters. CE 5 centimeters. BF, where's BF? BF is the whole thing, 12 centimeters. Find the length of BD. We'll put X here and DF. What is DF? 12 minus X. Now which triangle we can take? Look at carefully AEF triangle. AEF triangle. We can take the ratio because these two lines are parallel. So we can write AX to XF is equal to which one? 3 to 5. Now take ABF triangle. ABF triangle. What's the ratio? We can take AX to XF is X to 12 minus X. That's our second equation. Look at carefully. Left hand side, both are equal. So 1 equals to 2, you can equate. That means 3 over 5 is same as X over 12 minus X. Now cross multiply. You get 3 times 12 minus X is equal to 5X. 5 times X, open brackets. 3 times 12 is 36 minus 3X equals 5X. Take minus 3X to the other side. You get 8X. So 36 is equal to 8X. Divide by 8. 36 divided by 8 is X. So what's the value? 4 times 2, 4 times 9. 9 divided by 2 is 4.5. So that's the BD length. Now we need DF length as well. So what is DF? 12 minus X. So 12 minus X is 12 minus 4.5. That's DF. So what's the value? 0.5, 5, 5, 10, 1 remaining. So you get 5, 7. So 7.5 centimeters for DF value. Question number 8. In a triangle ABC, we need to draw it. ABC. The bisector of BCA. BCA, bisector. That means this angle is equal to this angle meets AB at X. The point P lies on BC such that PX is equal to PC. So that means somewhere you take somewhere here. PC is equal to PX. If PX is 9 centimeters, BX 5 centimeters and AX is 6 centimeters. Then find the length of BC. So you're asked to find out BC here. So I'll take Y. So you're asked to find out the Y value. Now look at carefully. It says the bisector. Bisector is that. So these two lengths are equal means, what can you say about this triangle? XPC triangle. XPC triangle is an isosceles triangle. So if this is X, this is also X. So we can write down PXC angle and PCX angle, both are equal because of isosceles triangle. Is triangle. Now look at carefully, this angle and this angle both are equal. Those are alternate angles. Alternate angles are equal means this line and this line both are parallel. So we can write PXC angle is same as XCA angle, but these are alternate angles. Alternate angles are equal. So therefore, I can write PX is parallel to AC. Now we can apply the ratio because these two lines are parallel. So what's the appropriate ratio? So if this is 9 centimeter, this is also 9. Now apply the ratio. If the whole thing is y, this is y minus 9. Now we'll take the ratio y minus 9 to 9 is same as 5 to 6. Now cross multiply and find out y. 6 times y minus 9 is equal to 9 times 5. Open brackets. You get 6y minus 54. 9 times 6, 54. 9 times 5, 45. So 6y equals, take minus 54 to the other side. You get 9 and 9, 99. So y equals 99 divided by 6. You get 6 times 1, 6 for 39. 6 times 6, 36 for 30, that's 5. So 16.5 centimeters for the y value. Y means the BC length. So BC length is 16.5 centimeters. Example 1. In the given figure PQRS and PAB are straight lines. BS line is parallel to AR. BR line parallel to AQ. Prove that PQ to QR is PR to RS. Now look at carefully. To be proved, PQ to QR, PR to RS. So we'll see PQ to QR ratio, which triangle we have to take. So we can take this triangle. PBR triangle. Now these two lines are parallel. Can you see these two? Then we can apply the ratio. So I can write PQ to QR is equal to PA to AB. That's the first thing. Then PR and RS. PR, RS. Which triangle we have to take now? This big triangle. These two lines are parallel. So we can apply the ratio for PBS triangle. What's the ratio? I can write PR to RS is equal to PA to AB. Now look at 1 and 2. Right hand side. Both are equal. So you can write 1 equals 2. So therefore, I can write PQ to QR is same as PR to RS. So that's the theory that we need to prove. PQ to QR is equal to PR to RS. Example number 2. The point D lies on the side BC of the triangle ABC. The line BE drawn parallel to AC meets AD produced at E. The line drawn from D parallel to AB meets AC at P. Prove that CP to AP is equal to AD to DE. So this is the one we need to prove, to be proved. CP to AP is equal to AD to DE. Now look at carefully which triangle we can take. CP to AP. CP to AP, this one. Which triangle? Can you see? If we can take this big triangle, we can apply the ratio because these two lengths are parallel. So I can take CBA triangle and write down CP to PA is equal to CD to DB. Then which angle? Now I need AD to DE as well. AD to DE is this triangle. These two lines are parallel. So apply a ratio for ABE triangle. ABE triangle, I can write AQ to QB. AQ to QB is equal to AD to DE. That's my second one. Now, when you take again ABC triangle, again we can write a ratio. We did this way. We wrote CP, CD to DB is CP to PA, this way. But when you take this triangle, ABC triangle, you can apply this way as well. This line with this line, these two are parallel. So how can you write the other ratio? ABC triangle, I can write BQ to QA, BQ to QA, or I'll write AQ to QB. AQ to QB, AQ to QB is CD to dB. That's my third equation. So what it says when you look at this one, AQ to QB, this one is same as CD to DB, this one. So what can you say? If these two are equal from 1 and 2, I can write these two are equal. So that's what we need. CP to AP, CP to AP is same as this one. So you get AD to DE. Exercise 14.2. Based on the information in the figure, show that OA to AB, OE to EF. So you need to prove OA to AB is same as OE to EF. Now look at the diagram. When you take OBD triangle, these two lines are parallel. What's the ratio we can write? OA to AB is OC to CD. When you take this other triangle, this triangle, these two lines are parallel. ODF. ODF triangle, what can I write? OC to CD is same as OE to EF. That's my second equation. Look at carefully. OCCD, OCCD, same ratio. So these two are equal. That means 1 equals 2. You can write as OA to AB is same as OE to EF. So that's the first part. Question number 2. Based on the given information in the figure, prove that AC to CE, AC to CE is same as BD to DF. Now we'll construct a line. So here, connect these two lines. AF connect. Now we can take two triangles. AEF triangle. What can you say about AEF triangle? These two lines are parallel. So we can apply the ratio. AC to CE is same as A, I'll put X or something here, AX to XF. That's our first equation. Now take the other triangle. ABF triangle. ABF triangle, I can write AX to XF is equal to BD to DF. That's my second equation. Look at carefully. This one is equal to this one. So 1 equals to, you can write down this one. AC over CE is equal to BD over DF. That's what we need. Question number 3. Based on the given information in the figure, prove that AP to PB, now AP to AB, BR to BC. So we'll take ABC triangle first. ABC triangle and these two parallel lines. these two parallel lines, I can write AP to bigger length, AB. Then that is equal to AQ to bigger length, AC. Now we'll take the same triangle with the other two parallel lines, these two. What I can write? I can write same thing, the bigger one to smaller one. I can write CQ, or I can write AQ to AC. AQ to AC. AQ to AC is BR to BC. Then I took smaller to bigger. Look at carefully, AQ, AC. AQ, AC. These two are equal. So 1 equals to 2. What can you say about this one? AP to AB is equal to BR to BC. So that's what we need to prove. Question number 4. In the triangle PQR, we need to draw the diagram. The triangle PQR, the point A lies on QR. A line drawn through A. So we'll take A somewhere here. A line drawn through A parallel to PR. Meets PQ at B. The line RCD drawn from R intersects AB at C and PQ at D. So that means any line here we can draw R. What's the line? RCD. RCD line intersects AB at C and PQ at D. If DBC angle is equal to BCD angle, this one, then prove that QA to AR is same as QB to CR. Now we'll look at this diagram. These two angles are equal. And according to this one, this is also equal, opposite angles. So what can you say about these two angles? So this length is equal to this length. So that's what we can write down. Now we'll apply the ratio between lengths. We'll apply ratio between lengths. We'll take the bigger triangle, PQR triangle. We can write QA to AR because these two are parallel. That's why we can apply the ratio. QA to AR is QB to BP. QB to BP. Now we can take another ratio. When you take P, this triangle, I'll take another color, red one. Look at this one, this triangle. What can I say about this triangle? These two lengths are parallel. I can write DB to BP. DB to BP is same as DC to CR. But I know DB is equal to CD, DC or CD. DC is equal to DB. So I can write, instead of DC, I can write DB here. This is first one, this is second one. When I take the second one, DC equals DB, these two are equal. So that means I can write from 2 CR is equal to BP. CR is equal to BP. Now take the first one. I can take the ratio. So QA to AR is same as QB. Instead of BP, I can put CR. So we get the same thing. Now we'll look at the converse theorem of the previous one. The converse theorem says if a line divides two sides of a triangle proportionally, then that line is parallel to the other side. So what's the converse? There's a triangle, and if two points are here, PQ, now it says if AP to PB is equal to AQ to QC, if this is given, we can show that PQ line is parallel to BC line. That's what we need to prove. So that's the converse theorem of the previous one. Now we'll take the same proof. So we'll connect PQ and we'll connect PC and BQ lines. So construction, connect PC line and PQ line. Now we'll prove that. Now we know this is AP to PB is AQ to QC. Now if you take this triangle APQ APC triangle, we know the area between the two triangles, the ratio between area is same as the ratio between bases. So we'll use that one. So APC triangle, I can write area of APQ triangle over area between PQC triangle is equal to AQ to QC. That's my first one. If you take this triangle, this one, ABQ triangle, ABQ triangle What's the area between APQ to BPQ? BPQ. What's the area? AP to PB. That's my second one. And look at carefully these two triangles. If the two ratios are equal, according to the given data, AQ to QC, APPB, this right hand side, both are equal. So 1 equals to 2. So therefore, we can say APQ area over PQC area is same as APQ area over BPQ area. Now, numerators are the same. So what can you say about this one? We can say the area of PQC is same as the area of BPQ. What's that? We'll figure out the areas. PQC. PQC area. This area. This area. And BPQ. BPQ. This area. These two are equal. What can you say about this one? These two areas are equal with the same base. So definitely these two triangles should be in between same parallel lines if the areas are equal. So we can apply other way. If areas are equal, with same base PQ, then it should lie in between same set of parallel lines. Should lie in between same set of parallel lines. Therefore, we can say PQ is parallel to BC. If the two areas are equal, then these two lines should be parallel. So that's the converse theorem of the previous one. Now we'll apply that theorem in example 1. Look at the triangle. Based on the information in the figure, find the value of AX to XF. Now we'll look at ABC triangle. ABC triangle, AX to, not X, AD to DB. What's the value? 4 to 3. What is AE to EC value? 6 to 4.5. Simplify. I can multiply by 10. So 60 to 45. Simplify. 5 times 9. 5 times 12. Then divide by 3. 3 times 4. 3 times 3. Now look at the ratios. Ratios are the same. So 1 equals 2. You get same ratio. That means what you can say? AD to DB is equal to AE to EC. then we can use the converse theorem. If the ratios are proportional, then DE is parallel to BC line. This line is parallel to this line. Then we can find out the ratio between AX to XF. If the lines are parallel, we can write AX to XF is equal to 4/3. So we can write other way around, AX to XF is 4/3 because the two lines are parallel. Example number 2. The point P lies on the side AB of the quadrilateral ABCD. The line drawn through P parallel to AC is given, meets BC at Q. Similarly, the line drawn through P parallel to AD meets BD at R. Prove that RQ is parallel to DC. So you have to prove this line is parallel to this one. So to show that, taking the converse theorem, we have to show that BR to RD is same as BQ to QC. So first we'll take this triangle. These two lines are parallel. So what can you say about the ratios? When you take ABC triangle, I can write PB or BP to PA is equal to BQ to QC. Then I can take these two triangles. The other triangle, I can take this triangle because these two lines are parallel. ABD triangle, I can write BP to PA is BR to RD. Now, in these two equations, left hand side is equal. I can write 1 equals 2. BQ to QC is equal to BR to RD. What it says? BR to RD is same as BQ to QC. Now the converse theorem. If these two ratios are equal, then straight away I can write, therefore RQ is parallel to DC. What's the reason? Converse theorem. Of proportionality. Converse theorem of proportionality. Exercise 14.3. Based on the information given in figure, show that AC is parallel to PQ. AC and PQ both are parallel. So we'll see the ratios. BP to PA, what's the ratio? 16 to 12. Simplify. 4 times 4, 4 times 3. You get 4/3. Then BQ to QC ratio 20 to 15. Simplify. 5 times 3, 5 times 4. 4/3. When you look at these two, the ratios are the same. So 1 equals 2. That means BP to PA equals PQ to QC. BP to PA, PQ to QC means, according to converse theorem, we can say PQ is parallel to AC line because of Converse theorem of proportionality. Question number 2. In triangle ABC, the point P lies on the side AB and Q lies on the side AC, such that AP to PB is equal to AQ to QC. So it's given AP to PB is equal to AQ to QC. Prove that QPB angle and PBC angle, the sum of these two angles is equal to 180. What are those angles? If these two are parallel, these are allied angles. Allied angles add up to 180. So they are basically asking, show that PQ is parallel to BC. According to Converse theorem of proportionality, if this ratio is equal, we can straight away write down PQ is parallel to BC. That's Converse theorem of proportionality. If these two are parallel, we can write CBP angle plus BPQ angle is equal to 180 because allied angles add up to 180 when the two lines are parallel. So Q, I can rewrite this as QPB angle and PBC angle is 180. Question number 3. In the given figure, AC is parallel to PR, AB is parallel to PQ. Prove that BC is parallel to QR. Now we'll take this triangle ABX triangle. What can you say about the triangles? These two lines are parallel. We can write down the ratios. XQ to QB is same as XQ to QB same as XP to PA because the two lines are parallel. Again, if I take these two, this triangle, AXC triangle, what I can write? I can write XP to PA is same as XR to RC. Now look at these two. This is the same as this one. So 1 equals 2. I can write XQ to QB is same as XR to RC. XQ to QB, XR to RC. Now look at this triangle. In this triangle, the ratios are equal, so proportional. According to Converse theorem, we can say therefore QR is parallel to BC. What's the reason? Converse theorem of proportionality. Question number 4. In the quadrilateral ABCD given in the figure, the diagonals AC and BD intersects at K. If AK is 4.8, KC 3.2, BK 3, KD 2, then show that DC is parallel to AB. Hint, the triangle KDC, take that the points A and B lie on DK and CK produced respectively. DK produced and CK produced. Now we'll look at the ratio between AK to KC. AK to KC. AK to KC is 4.8 to 3.2. Multiply by 10, 48 and 32. Then divide by 8. 8 times 6, 8 times 4. So simplify, divide by 2, 3 and 2, 3 over 2. Now look at the other ratio, BK to KD. That's also 3 to 2. So we can see these two ratios are equal. I can write AK to KC is equal to BK to KD. So what it means, if you take the two triangles, ABK and DC. AK is opposite to this one. That's same as KC. KC means this angle. So these two are equal. And if you take this ratio, BK, that means this angle opposite to this angle, KD is opposite to this angle. These two angles are equal. So if these two are equal means, what can you say about the two lines? Those are alternate angles. So alternate angles are equal means AB and CD parallel. So we can write in the diagram BAK angle is equal to DC K angle, as well as other way around, ABK angle is equal to KDC angle. Both are alternate angles. So alternate angles are equal. Alternate angles are equal means alternate angles are equal. Therefore, we can write AB line parallel to CD line. So that's what we need. DC is parallel to AB. Question number 5. In the triangle ABC, in the figure, the midpoint of the side BC. Midpoint of the side BC is D. The point O lies on AD. BO produced intersects AC at P. And CO produced intersects AB at Q. The line AD produced to R such that OD equals DR. Prove that BRCO is a parallelogram. BRCO. That means this one. So, we can say that. Why? Diagonals are bisecting each other. For a quadrilateral, if the diagonals are bisecting each other, we can say that's a parallelogram. So, we can write BRCO quadrilateral BD equals DC, OD equals DR. Diagonals bisect each other. Therefore, BRCO is a parallelogram. Second one, AQ to QB. AQ to QB. Where's Q? AQ to QB is AO to OR. So here, if this is a parallelogram, this one is parallel to this one parallel to this one. So when you take these two lines, these are parallel, BR and QC lines are parallel. So if we take ABR triangle, ABR triangle, what can you say about the triangle? ABR triangle. Two lines are parallel, so we can write AQ to QB is equal to AO to OR. So that's what we need in part 2. So that's because of BR is parallel to CQ. Third part. QP. QP is parallel to BC. So that means we have to show that AQ to QB is equal to AP to PC. We can do that. Here, can you see ACR triangle? When you take ACR triangle, this line and this line parallel. So we can write AO to OR is equal to AP to PC because I can write PB is parallel to, this line is parallel to CR. Now look at this one and this one. AO to OR, so this side is the same. AO to OR, AO to OR. So we can equate 1 and 2. So when you equate, we can write down AQ to QB is same as AP to PC. So AQ to QB, AP to PC. So in ABC triangle, the ratio is proportional. So the ratio is proportional means we can write QP is parallel to BC according to Converse theorem of proportionality. So I can write down what's the reason. Converse theorem of proportionality. Now we'll see what are similar triangles and equiangular triangles. What's the difference between those two? Now we'll take, when you go to a cinema hall, so you see the pictures bigger than the normal size. So let's take, there's an actress, and when you keep the light here, what happens with the lens? When you keep a lens there, you get a bigger picture than the actual one. So when you take the rays, something like this, what happens? You get something like this, a picture bigger than this. Actually, what happens? If we take the actual object, this is the object we are getting, and this is the image. If the actual length is like, we'll take 3 centimeter length, and if we measure the image length, if it's 30 centimeter length for this hand, what happens to the image? This is now 10 times more than the object. So if you take this one as this length is 4 centimeters, when you measure this one, it will get 40 centimeters. So 10 times more than that. But what happens when you measure the angle? The angle between here and here, if it's 30 degrees, do you think that's 30 times 10? 300 degrees? That is a reflex angle. It's not 300 degrees. You get the same angle here, 30 degrees. Here also, if it's 20 degrees, you get 20 degrees here. So actually what happens? You get the same shape figure, but the lengths are proportion. So angles are the same. Now we'll take another triangle, and if we want to enlarge this, so if we keep any light object here, if I want to enlarge this to a bigger triangle, what happens? I get something like this. If this is A, the image value A dash. So this length is same as this one. If you take this proportion, now if it's O, OA to A dash, if it's 10 times, then OB to B dash also same ratio. If this is C point, you are getting the same ratio. What about the angles? If this is alpha, this is beta, and this is gamma, you should be able to get the same angles, beta and gamma here. So what can you say about these similar triangles? So we call these are similar, same shaped triangles. Corresponding angles are the same, and the ratio between the lengths is proportional. What you call if the angles are equal? That's called equiangular triangles. So when you take similar triangles, what happens? You get the same shape figure with the proportional lengths. So the corresponding lengths are proportional in similar triangles. So here we are only considering triangles in this lesson. Now there's a theorem about the similar figures and the similar triangles and equiangular triangles. If two triangles are equiangular, then the corresponding sides are proportional. What it says? Now look at these two triangles. ABC triangle, A dash, B dash, C dash triangle. B angle is equal to B dash angle, that's given beta. A angle and A dash angle is alpha. Then third one, C angle and C dash angle. What's the value? It's given as theta. So the angles, the same angles you are getting in both triangles. So we call this is a equiangular triangle. So we can write ABC triangle and A dash, B dash, C dash triangle are equiangular triangles. Then, according to the theorem, what it says? If the two triangles are equiangular, then the corresponding sides are proportional. Corresponding sides means if you take the opposite to beta angle, that's AC. That's proportional to same length. Now, if this is beta, opposite to that is A dash, C dash. That's equal to, if you take the other angle alpha, opposite to alpha is BC, opposite to alpha is B dash, C dash. Now think about the other side. Opposite to theta angle, that's AB. So opposite to theta angle, that's A dash, B dash. So in this theorem, if you can identify the two triangles are equiangular, you can equate the ratios. So the ratios are proportional. Look at these two triangles. Check whether these are equiangular. Theta, alpha, beta. So both are equiangular. So first thing we can write PQR triangle and KLM triangles. I can write P angle is same as which one? M angle. Now write down the other one. Q angle is same as, that's theta. Theta is K angle. R angle is equal to L angle. So angles are equal, corresponding angles are equal. So we can write PQR triangle and KLM triangles are equiangular If the two triangles are equiangular, corresponding ratios are proportional. So corresponding ratios, we can write down opposite to alpha is QR, opposite to alpha is KL. Now take beta, opposite to beta, that's PQ. So opposite to beta, now KM. Next one, opposite to theta, that's ML. Opposite to theta here is PR. So we can write down the ratios between the lengths. Again, this is for any figure. So this is a quadrilateral. If the two, when you compare the two quadrilaterals, angles are the same. You get theta here, beta, alpha, gamma. All the angles are, corresponding angles are equal. So we can say these two figures are quadrilaterals are equiangular. Then you can take the same proportion. So we can write down in this one P, what's the quadrilateral? ABCD, quadrilateral, and PQRS, quadrilateral, both are equiangular. Then what can you write down about the ratio? You can write down appropriate ratio, corresponding ratios. Opposite to alpha, so when you take these two, so if we take theta beta line, that's BC. If you take theta beta line, that's BC. That's equal to theta beta, same line is PQ. If you take theta and alpha, that's AB. Theta and alpha, that's PS. Then alpha and gamma angle belongs to AD line. Alpha and gamma belongs to SR line. Then what's the other one? CD. Beta and gamma line, that's CD. Beta and gamma, that's QR. So why we can write down the corresponding ratios are equal? Because the two quadrilaterals are equiangular. So you can write down their B angle is equal to P angle, A angle is equal to S angle. Look at the figures. And C angle is equal to Q angle. D angle is equal to R angle. So we can write down the ratios like this. What's the theorem? When you get two similar. What's the theory we did now? When you get two equiangular triangles or any figure, you can write down the corresponding ratios and all are equal. We'll apply that theorem. Example number 1. In the two triangles ABC and PQ are in the figure. A angle is given equal to R, B angle is Q. Find the value of X and Y. Now if two angles are equal, definitely the third angle is equal to the other angle. So what can you say about these two triangles? ABC triangle and PQR triangle are both are equiangular. You can write down A angle is equal to R angle. B angle is equal to Q angle. So definitely C angle, third angle is equal to this one. Now we can write down the corresponding ratios. So corresponding ratios when you take, so we need x first. So we'll take this side. If you want this one, that's opposite to this one. So opposite to this one is 4. Then opposite to R angle is 15. So what is the corresponding length to that angle? That's 6. Now you can cross multiply and find out x. So x equals 15 over 6 into 4. Divide by 2, divide by 3. So 5 times 2 you get 10 centimeter length. Now try to find out the y value. You have to take the appropriate ratio. If you take y, that's opposite to this angle, Q angle. Y over, what's the suitable angle? There, B angle, that's 5 centimeters. So y over 5, you can take the same ratio here, 15 over 6. Now cross multiply and find y. Y equals 15 over 6 multiplied by 5. So divide by 3. 3 times 2, 3 times 5. 5 times 5, 25. 25 divided by 2, you get 17. This is 12.5 centimeters. 25 divided by 2, you get 12.5 centimeter as y. Look at example number 2. You have given an ABC triangle. The line PQ is drawn parallel to the side BC. Show that the triangles ABC and APQ are equiangular. ABC. Now look at carefully. These two lines are parallel. That means corresponding angles are equal. This angle is equal to this angle. This one is equal to this one, and this one is common. So when you take ABC triangle, A angle, you can take the other triangle as well, APQ triangle. A angle is equal to A angle. What's B angle? Is equal to P angle, and C angle is equal to Q angle. So these two are because of corresponding angles. Now what can you say about these three angles? Those are, so the two triangles are equiangular. Now the second part, find the values of x and y. If the two triangles are equiangular, the ratios are proportional. So ratio between lengths are proportional. So we'll apply the ratios. So I can write, if you take APQ, that's x length. ABC triangle, what's the length? The whole length, x plus 2. Then if you take 8 with 12. Then what about the other side? I can write at once. 6 with, what's the other length? 6 plus y. Now you can cross multiply separately and find out x and y. So I can take the first two. 4 times 2, 4 times 3. Now cross multiply. 3x, 2 times x, 2x, plus 2 times 2, 4. Now take 2x to the other side. 3x minus 2x, x equals 4. So we found x equals 4. Now take the other ratio. These two. When you take these two, what can you write? 8 over 12 is equal to 6 over 6 plus y, 4 times 2 and 4 times 3. Cross multiply. 2 times 6 is 12 plus 2y equals 6 times 3, 18. So 2y equals 18 minus 12. You get 6. So what's the y value? Y value is 3 centimeters. 6 divided by 2. So what is the theorem we used? We used when the two triangles are equiangular, you can equate the ratios between lengths. Exercise 14.4. For each pair of triangles given below, find the lengths of the sides represented by unknowns. So x. First check whether these are equiangular. This angle is equal to this angle. B angle is equal to F angle. Then definitely C angle is equal to D angle. So that means equiangular. You can write down the ratios. So opposite to this one is x, double angle, A angle, that's x. So opposite to E angle, that's 6. Opposite to B angle is 6. Opposite to F angle, that's 9. Now cross multiply and find out x. So 6 times 6 divide by 9. 3 times 2, 3 times 3, 3 times 2. 2 times 2, 4 centimeters. Look at the second one. Check whether these are equiangular. H angle is equal to K angle. I angle is equal to L angle. So definitely G angle is equal to J angle. Equiangular. So therefore, the corresponding ratios are equal. We need A, unknown letter. So opposite to this G angle. So A over, what's the corresponding length to that? That's 7. Opposite to double angle, I angle is 2. Opposite to L angle is 3. Now we can cross multiply and find A. A equals 7 times 2 over 3, 14 over 3. So 3 times 4, 12 and 2/3 centimeters. 4 and 2/3 centimeters you can take. Now we need to find B as well. So B, how can we find out? B is opposite to K angle. So opposite to H angle is 4. And you can take this ratio as well. So opposite to J is 7. Opposite to G is A. So G means A value we already found. Or I can take the other one. Without taking the unknown one, I can take the other side. Opposite to L angle is 3, then opposite to I angle is 2. Now cross multiply and find out B. B equals 3 over 2 times 4, 2 times 2, 3 times 2 is 6 centimeters. Part 3. First check whether these are equiangular. N angle is 90, that's equal to P angle. M angle is equal to R. So O angle is equal to Q angle. So this is equiangular. Now you can write down the corresponding ratios. So you need C. If you take C, that's opposite to P. C with 10. And 10 is opposite to this angle, that's 8 here. Now cross multiply and find out C. Multiply by 10, 2 times 4, 2 times 5, 2 times 2, 2 times 5, 25 over 2. That's 12.5 centimeters. Now take the other side because we need D as well. D is opposite to Q. Opposite to O is, that's 6. And I can take the previous ratio, 10 with 8. Now cross multiply and find out D. 6 times 10 divide by 8. 2 times 5, 2 times 4, 2 times 2 and 2 times 3. So 5 times 3, 15. 15 divided by 2. You get 7.5 centimeter for the length of D. Now take the next one. Check whether these are equiangular. T angle is given equal to X. S is equal to Y. And U angle is equal to W. So we can straight away write equiangular So if the two triangles are equiangular, the corresponding ratios are equal. Corresponding ratios, we need E. If you take E opposite to U angle, that's proportional to 5. If you take 10 angle is opposite to T. That's opposite to X is 10. 10 over 10. And what's the other angle? We need 8. If you take 8, 8 is opposite to this S angle. That means it's D. Now you can take separately and find out E and D. When you take these two, this is 1 and 1. So you get E equals 5. When you take these two, 10 divided by 10 equals 8 over D. Here you get 1. D equals 8. So 5 centimeters and 8 centimeters for E and D. Question number 2. Show that each pair of triangles in each of the following figures is equiangular and find the lengths of sides represented by unknowns. So how we find out these are equiangular? These two lines are parallel. That means this angle is equal to this angle. This angle is equal to this angle, and this is common. Why? What's the reason? Corresponding angles, because these two lines are parallel. So we can write A angle is equal to P angle. B angle is common. C angle is equal to Q angle. Why these two are equal? Corresponding angles. Now we can use the ratio. So we need x. X with 10. And if you take 4, PBQ triangle, 4 is opposite to this P angle. Then that becomes 10. So 4 with 10. Now cross multiply. You get 10 times 4 divided by 10. So 4 centimeter for x. Now, yeah, that's all for this question. And now we'll see the next one. In this diagram, so you have to take this triangle, that's DRS triangle. And what's the other triangle? EFD triangle. So this is 40. And D is common. D angle is common. So two angles are equal means definitely this angle is equal to this angle. So both are equiangular. So I can write down the R angle is equal to F angle. D angle is common. S angle is equal to E angle. So corresponding angles are equal. That means equiangular. So if the two triangles are equiangular, we can take the ratio. So what's DF ratio? This is 4 and this is unknown. We don't know. EF is 15. We know that. And DE is 5 plus x. Now we need to find out the x value. So appropriate ratio. So we can take, this is 5 plus x. Opposite to 40. Opposite to 40 is 4. What else we have? We have this angle. That's 15. Opposite to D angle. Opposite to D angle here is 9. Now divide by 3. This is 5 and 3 and cross multiply. 3 into 5 plus x is equal to 4 times 5. That's 20. Now 3 times 5 and 3 times x. 3 times 5 is 15 plus 3x is equal to 20. So solve for x. Take 15 to the other side. 20 minus 15 is 5. X is equal to 5 over 3. Write as a decimal. 3 times 1 for 20, that's 6. Again for 26. So this is recurring. You get a recurring 6. So 1.66 centimeters for x. Look at this one. Try to find out the equiangular triangles. These two are equal. Then these two angles are equal. GIH angle is equal to JIK angle. Why? What's the reason? Opposite angles. Then what's the other angle? Then if these two are same, so this is equal to this one. So G angle is equal to J angle. So we can say from these three equiangular triangles, so the ratio, we have to take the appropriate ratio. We need y, length y. Length y is opposite to 30. Opposite to 30 degrees is 4. Then we know 15 length. 15 is opposite to this angle. So what's the appropriate length there? Opposite to this angle is 8. Now cross multiply and find out y. Y equals 4 times 15 over 8. 4 times 1, 4 times 2, 15 divided by 2, you get 7.5 centimeters. Let's take part 4. What's the unknown letter? There are two letters, A and B. Now we'll take the two triangles, PST triangle and PQR. This angle is common. This one is equal to this one, corresponding angles, because these two are parallel. This angle is equal to this one. So I can write Q angle is equal to S angle and R angle is equal to T angle. So we can write this one as equiangular. Then take the appropriate ratio, A with 4. And if you take this side we need that 6. 6 is opposite to this angle. So opposite to this one is the whole thing. 6 plus 2, 8. Cross multiply, 6 over 8 times 4, 4 times 1, 4 times 2, 2 times 1 and 2 times 3. You get 3 centimeters for A. Now try the next one. Take the appropriate ratio. What's the ratio? B is here. So that means we have to take the full length. To this triangle, big triangle, that's B plus 5. That opposite to this angle. So what's the smaller one? That's 5. We can take the other ratio. Here, this is the big triangle, that's 8. And opposite to this one is 6 here. Now cross multiply and find out B. 6 times B, 6B. 6 times 5, 30. 8 times 5, 40. Now 40 minus 30 is 10. B equals 10 divided by 6 divided by 2. You get 5 over 3. When you divide by 3, what's the value? 3 times 1, 3. For 20, that's 6. So 6 is recurring. So 1.6 centimeter for the B value. Part 5. Which one is unknown? Length D and length C. What are the two triangles we can take? These two lines are parallel. This angle is equal to this one. This angle is equal to this one. Alternate angles are equal. So I can write S angle is equal to W angle. T angle is V angle. And this one is equal to this one. So that's common. SUT angle is equal to VUW. These two because of alternate angles. And this one opposite angles. Now, from these three, we can say equiangular triangles. Now, take the appropriate corresponding ratios. We need D. D is opposite to B angle, that's opposite to T angle. So, 9. Then we can take 9. If you take 9 centimeter opposite to W, that's equal to opposite to S angle, that's 6. We'll take the other side also. If you take C angle, C length is opposite to this angle. So, opposite to this one is 8. So, first thing you need to write down the appropriate ratio. Now, we can solve. When you take first 2, I can find out D. 3 times 3, 3 times 2. D is 9 times 3 divided by 2. 27 divided by 2, you get 13.5 centimeters for D. Now we'll solve for C. So 9 over 6 is C over 8. When you cross multiply this, you get C equals 9 over 6 times 8. 3 times 2, 3 times 3, 2 times 4, 4 times 3, you get 12 centimeters for the length of C. Question number 3. Based on the information given in the figure, name 2 pairs of equiangular triangles. We'll first find out the angles. These 2 lines are parallel. So that means this angle is equal to this. This angle is equal to this angle. So this is common. So what are the equiangular triangles? AGC triangle and ABD triangle. Then you need another pair. When you take this triangle, these 2 lines are parallel. This angle is equal to this angle and this angle is equal to this one, and this is common. So what can you write down? What are the 2 triangles there? BGE triangle and BAF triangle. Both are equiangular. When you take the second part, if BD is equal to 9, GC 6, AG, this length is 12, and GE is 2, and find out GB. GB is, we'll put X, and AF, we'll put Y. Now we found out the 2 triangles ACG and ABD triangles are equiangular. So we'll apply the ratios, corresponding ratios are equal. So I can write for the whole thing AB x plus 12 over 12, that's ACG triangle, is equal to, now take the bigger triangle, that's 9 opposite to A angle, 9 and 6. That's one equation. When you take the other triangle, what's the ratio we need? We need to find out Y. So if you take the bigger triangle ABF, I can write y with 2 is equal to, this is AB is 12 plus x over, this is opposite to this angle, that's x. First we need to solve for x and then substitute x there to find out y. 3 times 2, 3 times 3. Cross multiply, 2 times x, 2x, 2 times 12, 24, 3 times 12, 36. 2x equals 36 minus 24, you get 12, x equals 6 centimeters. Now we found out x is 6. You can substitute x there. Y over 2 is 12 plus 6 over 6. 12 plus 6 is 18 over 6 is equal to y over 2. 6 times 3. So cross multiply, you get y equals 3 times 2. Y also 6 centimeters. So here, what is x? What's the x value? X is GB. What's y? Y is AF length. Question number 4. According to the information given in the figure, name 3 pairs of equiangular triangles. 3 pairs. We'll take these 2 parallel lines. I can write this angle is equal to this one. This angle is equal to this one. Those are corresponding angles. So this is common. So what are the 2 equiangular triangles there? A, B, C triangle and C, D, E triangle. Then what's the other pair? We can take this line and this line. I'll take in blue color this line and this line. Then this angle is equal to this one. This one is equal to this one and this is common. So what are the 2 equiangular triangles there? BCF triangle and BED triangle. Now we'll take another one. What are the other triangles we can take? ABC, we took these 2. Can you see? I'll take red color. This triangle and this triangle. Red color one. This is equal to this one and this angle is equal to this one. This angle is equal to this one. So what can you say about those 2? Those are equiangular ABD triangle and CDF triangle. So those are the 3 pairs of equiangular triangles. Part 2. Find the lengths of the sides represented by A, B, C and D. Now because of these 3 equiangular triangles, we can take the appropriate ratios. When you take this one, This triangle, we don't know B and D, two unknowns. If you take this triangle, A and B, two unknowns we don't know. And if you take these two, AD, ADC, three unknowns are there. So which one we have to take separately and find out the values. So if you take ABC and CDE, ABC and CDE triangle, I can write down A with A plus 11, this with bigger length 11 plus A. That's same as 4 with C, 4 with C, this is 4 with C, 4 here, 4 with C. And same as if you take 5, 5 with 5 plus B. Now if you take the other two, BCF, BCF and these two triangles, what's the ratio? B with B plus 5, B with B plus 5, 4 with 6. That's equal to 4 with 6. And if you take the other side, that's D with 7 plus D. If you take the other one, ABD triangle and DCF triangle, I can write C with 6 and 11 with A, and what's the other length? D with 7. Now which one we can do first? Can you see from this part we can find B. So I can write B over B plus 5 equals 4 over 6. 2 times 2, 2 times 3. Now cross multiply. 3B equals 2B plus 10. So B equals 10 centimeters. Then we can use these two to find out D. I can write 4 over 6 is equal to D over 7 plus D. 2 times 2 and 2 times 3. Cross multiply now. 2 times 7 is 14 plus 2 times D, 2D equals 3D. Take D to the other side. You get D equals 14 centimeters. Now we found B and D. Using this equation, we can find A because we already know D. 11 over A equals D over 7. So what's A? A is, we can put 14 for D. So 7 times 1, 7 times 2. So 2A equals 11. A equals 11 divided by 2. That's 5.5 centimeters. Now we found A, B, D. Now we need C. You can either take this equation or this one. So we'll take these two. C over 6 is 11 over A. We found A is 5.5. So what is C? 66 divided by A. A I can write instead of 5.5, 11 divided by 2. Now can you see? 66 divided by 11 over 2, I can write as 66 multiplied by 2 over 11. 11 times 6, 6 times 2, 12 centimeters. So we found all the unknown letters. Now we have another theorem. If the three sides of a triangle are proportional to three sides of another triangle, then the two triangles are equiangular. This is the converse theorem of the previous one. So it says if two triangles are there, we label this is ABC, PQR, and if we know the triangles, if we know three sides of a triangle are proportional to the three sides of another triangle. So that means AB with PQ, AC with PR, or BC with QR. If we know something like this, the ratios are equal, we can say the two triangles are equiangular. Then we can say AB with PQ, that means this angle is equal to this angle. AC with PR. AC, that's B angle. PR here. PR means that's Q angle. Then A angle is equal to P angle. If two angles are equal, that means the third angle also equal. So that's the converse theorem of the previous one. So if you know three sides of a triangle are proportional, these three sides are proportional, we can say the two triangles are equiangular. Example number 1. According to the lengths of the sides given in the figure, show with reasons that the triangles ABC and PQR are equiangular. Name the equal angles. Now we'll take the ratios. PQ, AB. PQ with AB. 6 over 9, that's 2/3. RQ, that's 8. CA, that's 12. When you simplify, divide by 4. 4 times 2 and 4 times 3. 2/3. Then PR, that's 4. BC, that's 6. 4 to 6 also 2/3. What can you see? The proportion, the lengths are, the ratio between lengths are equal. So the ratios are equal. According to the converse theorem, we can say PQR triangle and BAC triangle both are equiangular according to the converse theorem. Converse theorem. Converse theorem about equiangular triangles. So if these are equiangular, what are the angles equal? We'll take the ratio PQ with AB. PQ and AB. That means R and C angles are equal. RQ. RQ is this angle. CA. CA is this angle. So we can say P angle is equal to B angle. So definitely the other angle, A angle, is equal to Q angle. So these are the angles that are equal to each other. Exercise 14.5. From the sketched triangles with measurements given below, choose 3 pairs of equiangular triangles. So we need to take the ratio and see. So we'll take smallest to largest. It's easy to compare. So what's the ratio between lengths? 2 to 3 to 4. Smallest to largest. What's the smallest here? 4 to 4.5 to 5. Now you can't keep as a decimal. So we'll multiply by 10, 40 to 45 to 50, and then divide by 5. 5 times 8, 5 times 9, 5 times 10. Third triangle, 8 to 9 to 10. You can't simplify. Next one, 10 to 15 to 17.5. Now you have to get rid of this decimal. So here multiply all by 2, 22, 32, multiply by 2, 35. 17.5 times 2. Now divide by 5, 4 to 6 to 7. Next one. What's the smallest? 6, 9, 10.5. Multiply by 2, 12 to 18 to 21. Now divide by 3. 3 times 4, 3 times 6 and 3 times 7. Last one. What's the ratio? Smallest to largest. 4 to 6 to 8. Simplify, you can divide by 2. 2 to 3 to 4. Now when you take the ratio between lengths, what can you say about the triangles? So look at carefully. We see this ratio and this ratio both are equal. So what are the equiangular triangles? ABC and ONM. ONM. What's the other one? When you take 4, 6, 7 here, can you see this one with this one? So we can write down PQR triangle and KLJ. Those are equiangular. And finally, this one and this one. So what are those triangles? DEF and GHI. Those are equiangular triangles. Question number 2. In the given figure, AB to EF, AC to ED, BC to DF, both all are equal. Name an angle which is equal to each of BAC, ABC and ACB. So we'll need to take separately. AB to EF. These two ratios, AB to EF. So AB, what's the opposite angle? This. EF. EF means opposite angle is this. So these two are the same angles. That's equal to AC. with ED. AC. AC is this one. So that means this angle, opposite to that is that. ED. ED is opposite to that is this. So you get that angle. So definitely this angle is equal to this angle. Now we can write down. After you select the appropriate angles, you can write down what is BAC angle. BAC angle is equal to DEF angle. ABC angle. ABC angle is equal to EFD. Then ACB. ACB is equal to EDF angle. Question number 3. In the given figure, AB is given 20 centimeters. BC 6 and CD 4 centimeters, DB 8, DE 2 and AE is 15. AB is parallel to CD. So this is parallel to this one. Also CD produced meet AE at F. So we need to extend this line, then this becomes F. Find the length of AF. So the whole length So here whole length is 15. You are asked to find out AF. We'll put X there. Now what are the equiangular triangles? So first we need to identify that and then apply the ratios between lengths. Look at this triangle. This angle is common. These two lines are parallel, means this angle is equal to this angle and this angle is equal to this angle. So we can write down the ratio. So we can write down the smaller one to the bigger one. So if you take the smaller one, what's this length? This length is 15 minus x. So I can write 15 minus x over 15. So here smaller to bigger. So smaller to bigger, so that's 2 over 10. So smaller 2 and the bigger one is 10. Now cross multiply. 15 times 10 is 150 minus 10x is equal to 2 times 15. You get 30. Now take 10x to this side, minus 10x becomes plus 10x, 30 to this side, 150 minus 30, 120. So x equals 120 divided by 10, you get 12 centimeters. So what is x? We took as AF length. So AF length is 12 centimeters. Example number 1. In triangle ABC, the points D and E lie on the sides AB and AC such that DE is parallel to BC. The line AY cuts DE at X and BC at Y. Prove that XE to YC is same as AX to AY. So here we'll take these two triangles for that. So when you take this side, these two lines are parallel. So if the two lines are parallel, we know that this is equal to this one is equal to this one. So equiangular triangles. AXE triangle and AYC triangle are equiangular. Why? We can write down A angle is same as A angle. Y angle is equal to X angle there, and C angle is equal to E angle. So these two because of corresponding angles. Then if these two are equiangular, you can write down the ratio between sides. So I can write XE. XE is the opposite of A angle, that's YC. Then we need AX. AX is opposite to E angle. Then that's equal to AY length. So this is according to the theorem. If the two triangles are equiangular, the ratios between sides are equal. Then we'll take the second one. XE and YC. DX with BY. Now when you take the other ratio, now we took these two sides. Now if you take the other two from the same triangle, what can you write? XE with YC is same as which one? This over this is same as AE over AC. If you take the bigger triangle, AE over AC. XE over YC is equal to AE over AC because of these two triangles are equiangular. Now we'll take this triangle. That's also equiangular, this and this one. Why? This angle is equal to this one angle is equal to this one, and this is common. So when you take ABY triangle and ADX triangle, both are equiangular. You can write down both are equiangular, means we can write down A angle is common, D angle is equal to B angle here, X angle is equal to Y angle. If these two are equiangular, you can take the ratio dx to by is equal to ax to ay. Now look at these two, ax ay equal, and we can write down these two are equal. So we can write down, therefore straight away we can write down xe over yc is same as dx over by. Exercise 14.6. Based on the information given in the figure, show that triangles ADE and ABC are equiangular. These two lengths are parallel. This angle is equal to this one. This angle is equal to this one, and this is common. So we can write down B angle is equal to D angle. C angle is equal to E angle. What's the reason? Corresponding angles. And A angle is common. So all three angles, corresponding angles are equal. Therefore, ABC triangle and ADE triangle are equiangular. Second part, prove that AD to AB is DE to BC. Now we can take, if the two triangles are equiangular, we can take the ratios between lengths. So if you take AD opposite to E, so same as AB. Then if you take DE, D is opposite to A angle, that's BC for the other triangle. And also we can write down, that's the second part, according to the theorem. Then to prove the third part, we'll take the other side, same triangles. If you take AE with AC, and if you take ED or DE, ED, then that's with BC. Now just cross multiply, interchange these two, you get AE over DE, I can take it here, and AC I can take it there. So AE over DE is equal to AC over BC. So that's what in the part 3. AE over ED or DE is AC over CB, same as BC. Question number 2. Based on the information given in the figure, prove that the triangles ABC and PQC are equiangular. PQC. C angle is common. This 90 and this 90 same, so this angle is same as this angle. So I can write C angle is common. QPC angle and ABC angle, both are 90 degrees, and A angle is same as Q angle. So because of these three, I can write down ABC triangle and PQC triangles are equiangular. Then part 2, we'll take the ratios. QC is opposite to 90 degree angle. So what is opposite to 90? That's AC. Now PQ is opposite to C angle. That's opposite to C angle is AB. Then the next side is PC. PC is equal to opposite to Q angle, that's opposite to A angle is BC. So that's the ratio between lengths. So according to theorem, so this is according to the theorem. What's the theorem? If the two triangles are equiangular, the ratio between lengths are proportional. Question number 3. In triangle ABC, B is a right angle, BD is the perpendicular drawn from B to AC. Prove that AB squared is equal to AD into AC. So we'll take ABC triangle and ABD triangle. B angle is 90 and ADB angle is also 90 degrees. And if we put this one is X, this is 90 minus X, because the sum of angles in a triangle is 90. If this is 90 minus X and this is 90, this is X. So we can see, if you take A angle, that's equal to DBC angle, that's X. And if you take the other angle, that's this angle is again 90 minus X, because when you take the sum of angles in a triangle, that's 180. So I can write ABD triangle is same as C angle there. So therefore ABC triangle and ABD triangle are equiangular. So we can take the ratios. So AB is the opposite to C angle. What's opposite to that angle? That's AD. Then we need AC. AC is the opposite to 90 degree angle. What is opposite to 90 degree angle? That's AB, according to the theorem. Now cross multiply. When you cross multiply, you get AB into AB, that's AB squared is equal to AD times AC. So that's what we need. Fourth question. PA is a diameter of the circle of triangle PQR. So passes through all these 3 points. And the line PB is perpendicular. The line PB is a perpendicular drawn from P to QR. Prove that the triangles PQA triangle and PBR triangle are equiangular. PQA, this angle, this triangle, and PBR, this triangle are equiangular. Now we need circle theorems. What can you say about this angle? This is PA is the diameter. So angle in a semicircle is 90 degrees. So PQA angle is 90 degrees and this angle also 90 degrees. So first we can write PQA angle is equal to PBR angle. Then what's the other one we can write? Can you see PQ is the chord, common chord, same segment angles are equal. So this is angles in one segment. So I can see this angle is equal to this angle. So when you take the other side, QAP angle is same as PRB angle. So if these two are equal, the other angle is the same. So I can write, what's the other angle? QPA angle is equal to RPB angle. So this one, what's the reason of this? Same segment angles are equal. What's the reason here? Semicircle angle is 90 degrees. That's the reason for this. So three angles are equal. So therefore PQA triangle and PBR triangle both are equiangular. Part 2. Those are equiangular. We can take the ratio between lengths. So PQ is the opposite angle to A angle. So what's the angle opposite to R angle? PB. Then we need PA. PA is the opposite to 90-degree angle. What's the opposite to 90-degree angle? That's PR. So you get the ratio between the lengths are equal because these two are equiangular. So this is according to the theorem. Question number 5. In parallelogram PQRS. It's a parallelogram. That means this is parallel to this one. This is parallel to this length. The bisector of QPS is the QS line. QPS meets the diagonal QS at A and the side SR at B and QR produced at C. So this is the bisector. So this angle is equal to this angle. Prove that PQ over PS is equal to PC over. So we need to find out equiangular triangles. These two are parallel and here these two angles are equal. Opposite angles. And here also these two angles are equal. And these two are parallel lines. This angle is equal to this angle. Now, which triangles we have to take? PQ is there, PS is there, and PC. Look at carefully. What are the lengths given? PC is there and PB. So we need to prove PQ over PS is equal to PC over PB. We need to identify what are the appropriate triangles we have to take. PQ is in which triangle? PQ is there and you have PC also. So that means we have to check this triangle. And what's the other triangle? PS length is there and PB. Yeah. So that's how you identify which triangles are appropriate here. So this one, we need to check PBS triangle and PQC triangle. Now X angle is there, so SPB angle is equal to CPQ angle, that's X. That one you already know. Then what else we can see? In a parallelogram, opposite angles are equal. So this angle is equal to this angle. So because this is a parallelogram, so we can write PSB angle is equal to PQC angle. What's the reason? Opposite angles in a parallelogram are equal. Then if these two are equal, definitely other angle is the same. That's PBS. PBS angle is equal to, this one is equal to PCQ angle. So we can see this is an equiangular triangle. So PBS triangle and PQC triangles are equiangular. Now we can take the appropriate ratio. So to take the appropriate ratio, we'll start with PQ. PQ is the opposite side to C angle. That means opposite side to B angle is PS. PQ over PS is equal to, now we need PC. What's PC? PC is the opposite angle to Q. PC over opposite angle to S is PB. So PQ over PS is equal to PC over PB according to the theorem. Question number 6. In triangle ABC, the point P lies on AB and the point Q lies on AC. Such that APQ angle is equal to ACB angle. Prove that AP to AB is AQ to AC. So these two angles are equal. Now we need to prove that AP to AB is AQ to AC. So when you rearrange, what can you see? If I take AP with AQ this way, AC with AB. So what are the two triangles? AP, AQ. So I can take this triangle and AC and AB there. So bigger triangle. So AC, this triangle, and see whether these are equiangular. So this angle is equal to that one. Here A is common. Then definitely this angle is equal to this angle. So these two are equiangular. So we'll take APQ triangle and ABC triangle. A angle is common and it's given APQ angle is equal to ACB angle. That's given. So definitely the other angle is the same. So other angle is AQP angle is equal to ABC angle. So because of these three, APQ triangle and ABC triangle both are equiangular. Then we take the ratio between the lengths. What are the ratios? If you take AP is the opposite side to this angle. That's AC. Now when you take the other side, we have AC, AQ. AQ means opposite to this angle. So AQ is equal to, opposite to this angle is AB. Now we'll cross multiply. When you cross multiply, what you get? AP to AB is equal to AQ to AC. Question number 7. The vertices of a triangle ABC lie on a circle. The bisector of BAC angle intersects the side BC at Q. These two are equal. And the circle at P. Prove that AC to AP is AQ to AB. Now you are asked to prove that AC to AP is equal to AQ to AB. Now we need to identify the appropriate triangles. AC is here and AP, so this one. So that means we have to take this triangle. AQ is this one and AB this one. So we need to check these two triangles. So we'll take ABQ triangle and APC triangle. When you take these two, we know that BAQ angle is equal to PAC angle. That's given. Now when you look at carefully, can you see when you take AC chord, these two angles are equal. Same segment angles are equal. So I can write ABQ angle is same as APC angle, same segment angles. If these two are equal, the third angle is also the same because 180 minus those two are the same. So I can write AQB angle is equal to ACP angle. Now these three angles are equal, so therefore ABQ triangle and APC triangle are equiangular. Now what can you say about the ratio? We need AC. AC is the opposite to this one. So opposite to this one is AQ. Then we need AB. AB is opposite to this angle. So opposite to this one is AP. Now, when you cross multiply here, we can change this one to here, this one to here. What you get? AC over AP is same as AQ over AB. Question number 8. In triangle ABC, the bisector of BAC, this angle. So that means this angle is equal to this angle, meets BC at D. The point X lies on AD, produced such that CX is equal to CD. It says this is X. CX is equal to CD. These two lengths are equal. Prove that the triangle ACX and ABD are equiangular and find out the ratio. Now these two are equal means this angle is equal to this angle. That's an isosceles triangle. So we'll take the two triangles that we need to prove. ACX. This one, ACX, this triangle, and ABD triangle, this one. Now look at the diagram. These two are equal means these two angles are equal. But we know this angle and this angle both are equal because of opposite angles. So we can write down, we need ACX triangle and ABD triangle. These two are equal. XAC angle is equal to BAD angle, that's X, that's given. Then this angle is equal to this angle. And this angle, we can say these two are equal means this angle is equal to this one. So again I can write this angle ADB. ADB angle is same as this angle AXC. Then this angle B angle ABD angle is same as ACX angle. Now these three angles are the same, so you can write down ACX triangle and ABD triangle, both are equiangular. Then we can take the ratios. So that's the first part. Second part, AB and AC. So what is AB? AB is opposite to this angle. So what's opposite to this angle? That's AC. Then we need BD. BD is opposite to X angle. So what's opposite to X angle? That's CX. Then ABAC is there, BD with DC. Why? CX is same as CD. So we can write CX is equal to CD. It's given. So we can plug there. Instead of CX, I can write CD or DC. So that's what we need to prove. Miscellaneous exercise, question number 1. In the rectangle ABCD, E is on DC such that AEB is 90 degrees. We'll mark E here. AEB 90 degrees. Prove that ADE and AEB and EBC are similar triangles. So what are similar triangles means? First we'll mark it. So this is, all these are 90 degrees and this side is equal to this side. This side is equal to the other side. What are similar triangles means? If triangles are equiangular, then those triangles are similar as well. Same shape with the lengths are proportional. Those are similar triangles. Now we'll see how we can prove this ADE triangle, this triangle, AEB triangle, this one, and EBC triangle. These three are similar triangles. What's the theory? If these are similar, the ratios between the lengths are proportional. So if we can show that these are equiangular triangles, that means definitely those are similar triangles. We'll see. When you take these two, ADE triangle and ECB triangle, if we take X here and Y here, we can see this is 180 and here X plus Y plus 90, 180. So here this is also X plus 90 is there. Then what should be this angle? This is 1, because the sum of triangles is equal to sum of angles in a triangle is 180. This is Y there, 90 there. So this should be X, and here this is Y there. Now we know this is a rectangle. So these are parallel. So if this is X, this is X. If this is Y, this is Y. So we can easily, we can check with the equiangular triangle. So ADE triangle we need, AEB and EBC and AEB triangle. So what can you say about the triangles? ADE angle, if you take ADE angle is 90 and AEB angle is 90. Here BCE angle is 90. If you take this angle DAE angle, that's Y angle, is same as ABE angle, that's same as CEB angle, that's Y. Then we'll take the X angle, DEA angle is equal to EAB angle, and in this triangle that's equal to EBC angle, that's X. So angles are equal, so we can say these three triangles are equiangular triangles. So therefore ADE, ECB and AEB triangles are equiangular. Then we can take the ratios. So similar means, so we know according to the theorem, if triangles are equiangular, they are similar as well. So therefore, you can write down these three triangles are similar triangles according to the theorem. In ABC triangle, we can see B angle is 90 degrees, AB is 5 and BC is 2. The perpendicular bisector of AC intersects the side AB at Q. So when you draw the perpendicular bisector, it intersects at Q. Show that the length of AQ is 2.9. So bisector means this length is equal to this length. Now, according to Pythagoras theorem, this is a right angle triangle, I can find out the length of A. So I can write AC squared is equal to AB squared plus BC squared according to Pythagoras theorem. AC squared is A and A, that's 2A, whole thing squared. AB squared is 5 squared. BC is 2 squared. 5 squared is 25. 2 squared is 4. Here 2 into 2, 4, 4A squared. 25 plus 4, 29. 4A squared is 29, so A squared is 29 over 4. When you take the square root, plus or minus 29 over 4, take the positive value, I can write as root 29 over 2 because square root of 4 is 2. That's the A value. Now they are asking, show that AQ is 2.9. Now, according to this triangle, we can show that these two triangles are equiangular. AQ, we'll put X here, this triangle and the bigger one. So we'll take AQ X triangle and ABC triangle. B angle is equal to X angle there, that's 90 degrees. And if this is X here and this is Y, X plus Y is 90. X plus Y plus 90, 108. If this is X, this is 90, this is Y. So you can write X angle is 90, QA X angle is same as BAC C angle. So that's common. Then the next one, AQX angle. That's Y angle. Y angle is same as ACB angle. That's Y. So we can show that these two are equiangular. So therefore, AQX triangle and ABC triangle both are equiangular. Now, we found out the two triangles are equiangular. Then we can take the ratio between lengths. We need AQ. AQ is the opposite to 90 degree angle. Opposite to 90 degree is that's AC. Then we need another length. We know this length, AX length. AX is opposite to Y. So what is opposite to this one? That's AB length. That's 5. I'll first write down AB and then substitute the values. Now substitute the values from this AQ, AC. AC is 2A. AX is A. And AB is 5. Now, cross multiply, you get the answer. AQ is equal to 2A into A, 2A squared over 5. But we know A squared is 29 over 4. We can substitute 2 over 5. Instead of A squared, I can substitute 29 over 4. 2 and 2, you get 29 divided by 10. 29 divided by 10 is 2.9 centimeters for AQ length. So that's what we need. Show that AQ length is 2.9 centimeters. Question number 3. In triangle ABC, I'll take blue color. In triangle ABC, PQ drawn parallel to BC. This line is parallel to this one, where BC meets the side AB at P and the side AC at Q. The line CP and BQ meets each other at S. SR drawn parallel to AB meets BC at R. So a line parallel to this one. So this line parallel to this one, and this is R. Prove that BRORC is equal to AQAC. I'll put a letter here, T. Now we need to take the ratio. What we need to prove, BR to RC is equal to AQ to AC. BR to RC is AQ to AC. Now here, what can you say about BRTP quadrilateral? This is a parallelogram. It's a parallelogram. Why? This opposite sides are parallel. Then I can write, instead of BR, that's equal to PT. Opposite sides are equal. Now, I want to prove this. So, I'll take, instead of BR, that's PT. So, if I can take a relationship between PT and RC, RC is there, we can find out this ratio. So, what can you say about these two triangles? This triangle and this triangle. These two triangles. These two are equiangular. This angle is equal to this angle. This one is equal to this one, and this is opposite angles are equal. So we can take PTS triangle and SRC triangles and write down a ratio, because equiangular means the ratios you can write down. So we can write these are equiangular. So because of that, I can write PT with RC is equal to, what's the other length I need? I need PT with RC and PS with SC. This side is equal to this one, or I can take opposite side. I'll write both. If you take this one, this is ST. PT is this side. And if I take PS or ST, what's the appropriate side? ST is opposite to this. That's SR. And other angle, ST, is opposite to this one. So, opposite to this angle is PS. That's equal to SR. PS is this one, is SC, not SR. SC. So, we get the ratio. Now, look at carefully. We have BR. I can replace this as PT. So, this is PT. And I need AQ and AC now. AQ and AC. That's these two triangles. Now take these two triangles. These two triangles. Now we have this relationship. We'll put this one as 1. Now we need to look at, now we need to take AQ somehow. So to get AQ and AC, what are the two triangles we need to take? We need to take APQ triangle and APQ triangle and ABC triangle. Again, these are equiangular. This is common and these two lines are parallel. So, this angle is equal to this one. This angle is equal to this one. So, we can show that these are equiangular. Because of that, we can take the ratio PQ to BC, PQ to BC, this length to BC is same as AQ to AC. So this one we can take as second one, and we need now PQ with BC. So if we take these two triangles, what can you write? PQS triangle, PQS triangle. This one and this one also equiangular. PQS triangle with BSC triangle. Both are equiangular because these two are parallel. So what we can write down there? We can write down PQ to BC is equal to PQ to BC is equal to PS to SC. PS to SC. Now look at these two. This side is equal, so this side is also equal. Now, can you see here? First one, PSOSC is there. So, when you consider all three equations, 1, 2 and 3. From 2 and 3, I can equate this one, PQ to BC. These two are equal. That means I can write AQ to AC is PS to SC. Now look at 1 and 2. This is PS over SC is same. Here we can write down AQ to AC is equal to PT to RC. Now, what we need to prove? AQ to AC is BR to RC. PT is equal to, we prove that. What's PT? BR. We can replace PT with BR. Then I can write down BR to RC is equal to AQ to AC. So that's what we need to prove. BR to RC is equal to AQ to AC. So we need 3 similar triangles to show this proof. In this lesson, we discussed about equiangular triangles and similar triangles. So do all the exercises and examples to practice and then thorough with the theorems.